Hello viewers, welcome to the brand new series titled Innovators Speak. Today we will talk on the latest innovation in the health sector, world's first needle-free diabetes test. To talk more on this, we are being joined by the person who invented this product, Professor Paul Dastoor. He is a professor in physics in the School of Mathematical and Physical Science and the director of the Center for Organic Electronics at the University of Newcastle, based in New South Wales, Australia. Addressing global issues as diverse as the energy crisis, diabetes, and mining safety, Professor Paul Dastoor and his team are at the forefront of the emerging field of organic electronics. Congratulations, Professor Paul Dastoor and your team on this new innovation, and we welcome you to this very special program.
Thank you, Ameya. It's lovely to be here and lovely to talk to your viewers.
I will start with my first question. Please tell our viewers what is the technology which you have invented and how different it is from the traditional one.
Sure. Yeah, so in order to explain how the technology works, I have to take a small step backwards, if I may, Ameya, and to talk a little bit about the materials that we use. So the technology is based on semiconducting polymers. These materials are remarkable. We're most used to polymers or plastics being electrically insulating, but these materials are actually semiconducting. And this was discovered in about 1977, 1980, that you could make these materials. Since then, they've been used in a variety of electronic devices. And what we have done is developed these inks, these electronic inks, to the point where we can actually print transistors. Now, a transistor, as I'm sure many of your viewers will know, is a very sensitive amplifier. And so what we realized was that if we were able to put a sensing molecule into these transistors, which are all based on carbon, and the sensing molecules are based on carbon, we thought that we would be able to make a sensor. Now, this was all thought about in 2005. So this gives you a bit of an idea of how long it takes to develop these sorts of scientific innovations. Anyway, the biomolecule that we incorporated was an enzyme known as glucose oxidase. And that's an enzyme that detects glucose. So effectively, it's nature doing all of the work for us, really, because the enzyme to do the detection is already there. What we have done is been able to integrate it directly into a transistor structure that we can then print, because these inks are liquids and we can print them at really low cost. And so we've been able to show that we were able to develop transistors or sensors that were highly sensitive. It turns out, you see, that there's glucose in your saliva, and it follows the concentration. The concentration of the glucose in your saliva follows the concentration in your blood. It's just that it's about 100 times lower concentration than in your blood. So I'm sure you can see that you need to have a very sensitive detector. And so we were able to show that we could detect at those low levels using these saliva-based sensors, or using these sensors, and therefore could detect glucose in your saliva.
My next question will be if you could tell our viewers the new product which you have developed, how does it work, and how a person gets the result in how much time?
Sure. Yes. So the concept is that we have a small strip on which is printed the transistor, and then we apply the sample containing glucose on that strip, and it's the response of the electronics in the strip changes depending on how much glucose is there. And that's picked up by a small reader, which can then communicate or ultimately will communicate with, for example, your mobile phone and give you your glucose reading. And so really, it's quite straightforward. As far as the patient is concerned, they'll just have a strip which they will put a sample of their saliva on or put it directly in their mouth and then test. Now, your question might be, do you put it in your mouth? And the answer is we don't know yet. We're working with colleagues at Johns Hopkins Bloomberg School of Public Health, and they're experts in actually salivary sampling or saliva sampling. And so we're working with them on developing the best way of either sampling the saliva, or maybe we'll put the electronics directly into the sampling method.
Okay, so my next question will be like when you did this research and when you came to the conclusions, what was the error margin if you compare it with the conventional way of taking a blood sample and then doing the test? So what were the results? What was the error margin if you compare the two technologies?
Yeah, so the issue now, of course, is that we actually have to have a very sensitive test because the concentrations are now much lower. And in fact, there are no standard regulatory protocols for saliva-based testing yet. So what we've had to do is actually create a technology that has even, if you like, less absolute error, I suppose, than conventional blood glucose sensors. And we're still working on that. As we start to move towards large-scale manufacturing, and indeed the announcement last week was that we've been funded by the Australian government to build the first factory to manufacture these devices, we will be developing all of those protocols and all of those sensitivity measurements to ensure that we do have sufficient accuracy for these devices.
If I could again ask you, if I'll revisit my question, what was the error margin if you compare it with the conventional way of testing? What was the error margin?
So the error margins for your standard blood glucose sensors
Yeah.
are set out. They have to lie within 15% of the errors. And so at the moment in the laboratories, we're able to develop devices that also meet those sort of error margins as the same as for blood glucose sensors.
Okay. My next question will be, have you started the clinical trials and could you find any serious adverse effects of this particular test?
So no, we don't anticipate any adverse effects. There are no toxic materials in the inks. They're all based on carbon. There are no heavy metals or any unpleasant materials in them. In terms of clinical trials, that's exactly what we're preparing for now. So the new manufacturing facility will allow us to develop sufficient numbers of devices so that we can actually start clinical trials across the region. So that's our next step.
When I published this story, I had few questions from my readers. So I just wanted to put it across. There were few safety concerns, like was there any chances of infection or cross infections, or there were concerns regarding chemical toxicity, this particular thing, or were there any risk of oral cavity kind of issues?
Those are good questions. Those are good questions. As I said, no, we don't think there are any toxicity issues. None of the materials are toxic. And indeed, exactly how we sample is not clear yet. It may well be that you don't put the device in your mouth, but we'd actually have a separate sampling system that will extract the saliva and then put it on the device. So that's still an open question. In terms of the other part of your question, I think, was associated with
oral cavity issues.
Are there any oral cavity issues? No, I don't think so. We don't anticipate any issues there in terms of the technology.
Professor Paul, when we talk about putting this innovation on a commercial platform, when do we expect the first product in the market, and what are the timelines set, and what are the cost factors? How would it be costing for a common man to do these kind of tests?
Yeah, those are great questions, Ameya. I mean, in terms of the timelines are now quite short. So the plan will be that we will have the manufacturing facility up and running within 18 months. We are actually building a printing factory. And then we expect to have the first devices commissioned perhaps even within 2 years. So I anticipate that we could have products on shelves within about 2 years. In terms of the cost, I can't really comment on that from the point of view of a commercial basis, but what I can say is that intrinsically the cost of manufacture is very low. And so we're talking about devices that are only going to be a few cents to manufacture.
That sounds great. Being a monopoly product, What is the status on the patents, or have you applied with the US FDA or any other international agency for approvals, and what's the funding pattern of this project?
Okay, so 3 questions. Let's
Yeah.
see if I can answer them one at a time. In terms of the intellectual property, yes, that's all secured. And indeed, we are developing new patents all the time. And so that portfolio is growing for our commercial partner across all aspects of the technology. In terms of the approvals and FDA approvals, we're going through those right now. And so we have regulatory affairs taking place with our commercial arm. And your third question was?
Approvals from the international agencies like US FDA or WHO.
Yeah, so indeed, we're going for FDA approval right now, and that's being developed. And of course, the challenge here again is that there are no established regulations for testing glucose in your saliva because it's not done yet. And so that actually will involve some work with the regulatory authorities to develop the appropriate protocols.
And lastly, what's your self-assessment about the product and the promisal of claims?
Oh, I don't know what in terms of what I think of the product. Look, we've been working on this technology, as I said, since about 2005. So that's what, 16, nearly 17 years now.
17 years.
So, and it started from very, very fundamental scientific research, really trying to understand how we can integrate biological molecules with organic electronics. And over the years, we've seen that technology develop. And so we're really excited. I'm really excited about being able to see the final implementation of a technology that has taken 16 years to develop and getting it into the hands of people. I mean, there are nearly 500 million people with diabetes worldwide. And at the moment, what do they have to do? They have to stab themselves 4, 6, 10 times a day and draw blood. It's painful, it's uncomfortable. If we are able to deliver an absolutely needle-free test for glucose, I think that'll be a big deal.
That's a great service to the humanity, and that brings me to the end of this program. Thank you very much, Professor Paul Dastoor, for joining on this very special program. It was very informative. I congratulate your team, and you are doing a great service to the humanity, and the kind of innovation you are bringing, it will be a game changer going forward. This is Ameya Sathaye for sarkaritail.com and diplomacyindia.com, signing off from New Delhi. If you have liked this video, please subscribe to our channel. You can share this with your other friends and colleagues. Bye for now. Thank you very much.